Any other questions?
We might as well ask it. And then what would I then mean? Because I know there's identity, but
Right, so I is the identity matrix, which just means it looks like one of these guys. Again, so it kind of depends on what n is, the dimension that I'm talking about. That's why it's sort of harder for me to describe, that's why I sort of said that there's not just one identity matrix. There's sort of one for each dimension.
got you.
But they always look like this. One's down to diagonal and 0, and I'm just going to write I for all of them, basically. So maybe I could do like I3 or I4, so forth, to indicate the dimension. But anyway, yeah, it's sort of a confusing thing. But any other questions? Okay. Cool. Yeah, that's sort of an annoying thing is that we have, like I said, not just one identity matrix. There's one for like each dimension. And that's just because I have matrices of all kinds of different dimensions. And so I need to sort of take care of all the possibilities. When it's numbers, I just have numbers. So I just have the number 1. But matrices, I can have 2x2s or 3x3s or 4x4s and so forth. So I kind of need an identity matrix for each case of that. Cool. So, and then I'll just stress again, whenever I write, I will never use capital I for anything other than the identity matrix. So whenever you see capital I, that means identity matrix, which means it's one of these matrices. The 1 down the diagonal and 0 is everywhere else. Okay. Oh, okay. So the last thing I want to mention today is just some properties of multiplication. Sort of like I did yesterday for addition and scalar multiplication. I'm just going to write these on the board and not really hamper on them too much. Although I need to point out one thing in particular that I mentioned already, but I want to hammer home. So first things first, we have the same kind of properties that we would want. We have like the distributive property. So if I have 3 matrices, I have like A plus B times C. I could distribute and get AC plus BC, and so forth. I could distribute the other way too. So I was multiplying on the left instead. I could also distribute this. So matrix multiplication distributes over matrix addition, just like normal multiplication distributes over normal addition. And there's also this, we call the associative property, so that if I'm going to multiply 3 matrices, then it doesn't matter if I do B times C first and then multiply by A, or if I were to multiply A and B first and then multiply by C. That doesn't matter. So this is called associative. This was just distribution. So it doesn't matter. If I'm multiplying 3 matrices, it doesn't matter if I do these 2 first and then do that one, or if I do these 2 first and then that one. I'll get the same result. But here's my big caution. Here's something that fails. Is that in general, A times B does not equal B times A. Okay. All my colored markers decided to die today, apparently. It's no good. So I can't highlight this as much as I wanted to. How annoying. Okay, well anyway, circled in black, I guess. The point being, this is super important for you guys to know that this is not true. You cannot, A times B is going to be different from B times A almost all the time. Very rarely will it work out that way, that they will be the same. So just notice, matrix multiplication is not commutative, would be the word. It's not commutative. The order matters. A times B is not the same as B times A. And that had to do with our definition of matrix multiplication, because I took rows of the thing on the left times columns of the thing on the right. if I flip the order, then all of a sudden now I'm taking, instead of taking columns of B, I'm taking the rows of B. And instead of taking the rows of A, I'm taking the columns of A. So I'm just dealing with different things. So we should expect that these will not be the same. Just because to do each of these requires me to just do different things entirely. So not commutative. Matrix multiplication is not commutative. Okay, I want to stress that because that's like really, it's super important. This is another major difference between just normal arithmetic with numbers and doing arithmetic with matrices. If I multiply two numbers, it's commutative. Doesn't matter what order I multiply them in. But for matrices, it totally matters what order you multiply them in. So be very careful if you're asked to multiply two matrices. Make sure you're doing it in the correct order, or else you will get a very different answer probably. Okay, I think that's the last thing I want to say. Does anyone have any questions to finish this off? How much time we have left? We still have, oh, we only have 10 minutes left. Wow, I talked longer than I thought I did. Oops. Okay.